Alright guys, we're back today to look at the second part of lesson 5.4, which is on solving radical equations. And we are going to start today with solving equations that have rational exponents, because we know that rational exponents are very closely related to solving things with radicals. So the first thing we want to do is our first step, just like yesterday, is to isolate the expression that has either the radical or the rational exponent. So in this case, that's already done for us because this entire trinomial is being raised to the power of 5/2. And so our next step is to get rid of that power of 5/2. And so what we do is we raise both sides of this equation to the reciprocal power. We do that for the reason that when you do power to a power, you actually multiply your powers, and so we're going to have 5/2 times 2/5, and when you multiply a number by its reciprocal, you get 1. So it cancels out the rational exponent. Okay? So on the left-hand side of my equation now, I just have x squared plus 5x plus 5. And then on my right hand of my equation, I'm starting with a really simple number here, 1 to the 2/5 power, which is the 5th root of 1 squared. Well, the 5th root of 1 is just 1, squared is 1. So this number over here on the right is just 1. And so we have a quadratic equation, which needs to be solved by factoring, hopefully. So we want to set equal to 0. So I'm going to subtract 1 over to the left to keep my quadratic term positive. And I have x squared plus 5x plus 4 equals 0. And because my a value is 1, I can express factor this. And factors of 4 that add up to 5 are 4 and 1. So then we get x equals -4 and x equals -1. And we should check those really quickly to make sure that those are both viable solutions. So I'm going to do a pretty quick check. If x is -4, we're going to have -4 squared plus 5 times -4 plus 5 to the 5/2 power equal 1. So -4 squared is 16. 5 and -4 is -20 plus 5. And that'll be -4 plus 5 is 1. To the 5/2 is 1. So that one works. And then let's double check -1 using a calculator. So I'm going to show you how to do some of this step in the calculator. So if I put in -1 for x, first of all, I'm in parentheses, but now I want to put -1 in parentheses to square it. And then I have plus 5 times -1 plus 5. Close those parentheses, and then I'm going to raise it to the 5 divided by 2, which is 5/2 power. If you are not using one of our graphing calculators that takes you up into the exponent, you have to put parentheses around the 5 divided by 2. And we get 1, which is what we wanted it to equal. So using -1 for x is also a solution. Okay? Alright, let's try another one. So the first thing I'm going to do is make sure that my expression with the rational exponent, rational means fractional, is isolated, which it is. So then I'm going to raise both sides to the reciprocal power. Reciprocal of 3/2 is 2/3. And now over here, 3/2 times 2/3 is 1. So I just get my x plus 18. And over here, when you multiply, because we're doing power to a power, 3 times 2/3 is 2. So we get x minus 2 squared. So I'm going to multiply that out. And that's going to give me x plus 18 equals x squared minus 2x minus 2x plus 4, which is x plus 18 equals x squared minus 4x plus 4. I'm going to move over to the right because I want my quadratic term to stay positive. So subtract x and 18. And I get 0 equals x squared minus 5x minus 14. Factors of negative 14 that add up to negative 5 are negative 7 and positive 2. So I get x equals 7 and negative 2. And so I'm going to check those in my calculator real quick. If x is 7, let me turn my brightness down here a little bit for you. If x is 7, we're going to have 7 plus 18 raised to the 3/2. I'm going right to the original equation. And I get 125. And then the right side of the equation, I'm going to have 7 minus 2 to the 3rd power, which is 125. Okay, so 7 works. And we're going to try negative 2. So negative 2 plus 18 raised to the 3/2 is 64. And then the right side of the equation, negative 2 minus 2 to the 3rd power is negative 64. So when I check that one, it does not work. So that is extraneous. And the reason why that one's coming out as extraneous is because when I go back to my original equation, I'm taking a square root, which assumes positivity. So remember, we have some serious domain restrictions when it comes to square root functions. And in this case, we're not going to be able to use negative 2. That's an extraneous solution. That is negative 2. So we reject it. All right, let's take a look at a couple more of those. So for this first one, we have to first isolate our expression with the rational exponent. So that means I'm going to add 14 over to the right first. So I'm going to get x squared minus 3x minus 6 to the 3/2 power equals 8. And now I'm going to raise both sides to the reciprocal power 2/3. And so over here on the left, 2/3 and 3/2 cancel each other out, because when you multiply them you get 1. And we get x squared minus 3x minus 6 equals 8 to the 2/3 power, which, remember, we should be able to do that without a calculator. That's the cubic root of 8 squared. So the cubic root of 8 is 2 squared is 4. So I'm getting 4 over here. And so I'm going to subtract 4 to the right. I'm sorry, to the left. And I get x squared minus 3x minus 10, which factors? Factors of negative 10 that add up to negative 3 are negative 5 and 2. And so I get 5 and negative 2 is potential solutions, which we're going to check. I'm going to start with 5 squared minus 3 times 5 minus 6 raised to the 3/2 power minus 14. I went back to the original equation, and I get negative 6, so 5 works. Okay, now when I go to square negative 2, I need to put that in its own set of parentheses to square it. Minus 3 times negative 2 minus 6 raised to the 3/2 power minus 14 is negative 6. So that's what we needed, and so both of these are good solutions. Okay? And let's do another one. So my expression with the rational exponent is already isolated. So we're going to go ahead and raise that to the reciprocal exponent, 2/5, which is what we're going to do on the left side as well. Raise to the 2/5. And so now what ends up happening is we end up with x plus 8 raised to the 2 times 2 is 4/5 power. Now these over here cancel, so we have x minus 10. So that did not get rid of the rational exponent on the left, which means we got to think of a different approach for this one. And so what I think I'm going to do is put a pause on this problem. And we will come back and discuss this one when we have a few more tools in our toolbox. Okay? Alright, so let's move on and look at example 5 now. 5 has 2 radical expressions in it. And so when we were solving yesterday with one radical expression, our goal was to isolate and then either square to get rid of a square root, cube to get rid of a cube root, etc. So we're going to start the same way here. I'm going to bring down my original equation. And what I'm going to do is I'm going to isolate one of these rational expressions, or radical expressions, excuse me. And I'm going to do that by adding square root of 2x to both sides. And that's going to give me square root of 9, x plus 9 equals 3 plus, or let's do square root of 2x first, plus 3. So at least one of these radicals is now isolated. And so what I'm going to do is I'm going to square both sides. And when I square the right side, it's a binomial, so I got to keep that in parentheses. And on the left, the square root and the square are going to cancel each other out. And so I get x plus 9 equals, now a binomial squared is square root of 2x plus 3 times square root of 2x plus 3. So I have x plus 9 equals, we got to distribute this out. So square root of 2x times square root of 2x is just 2x. And then I get plus 3 square root of 2x plus 3 square root of 2x plus 9. And so I'm going to combine like terms. Meaning I can combine the two radicals, so 6 square root of 2x. And now we're in the same situation we were in a second ago. We want to isolate the radical expression, so I got to get rid of everything else. So I'm going to start by subtracting over to the left 2x and 9. And so on the left hand side I get negative x, the 9's canceled out, equals 6 square root of 2x. And then I am going to get rid of my radical over here. By squaring both sides again. Okay? And so negative x times negative x is x squared. 6 squared is 36. Square root of 2x squared is 2x. Sorry, that's going to be 2x. I was going to say 4x, but it's 2x. Right, because the square root and square cancel each other out. So we get x squared equals 36 times 2x is 72x. And I'm going to subtract 72x over to the left because this is a quadratic equation. And so I get x squared minus 72x equals 0. And this one we solve simply by factoring out a GCF. So I can factor out an x, and that gives me x minus 72 equals 0. And for solutions I get 0 and 72, which of course we have to check. So when I check that in my original equation, I get square root of, well, 0 plus 9 is 9, minus square root of 2 times 0 is 0, and I get 3, which is what I needed to get. So 0 works. And now we want 72. So square root of 72 plus 9 minus square root of 2 times 9. Oh, I'm sorry, 72. 2 times 72, because x was 72. Equals, I'm getting negative 3 when I needed to get positive 3. And so you can see here we've got an extraneous solution. We must reject 72. So 0 is our only solution. Okay. All right, let's try another one here. Start off by isolating our radical expression. So I'm going to add square root of 3x to both sides, which is going to give me square root of x plus 4 equals square root of 3x minus 2. Square both sides, and I get x plus 4 equals square root of 3x minus 2 times square root of 3x minus 2. So I have x plus 4 equals square root of 3x times square root of 3x is 3x minus 2 square root of 3x minus 2 square root of 3x plus 4, which gives me 3x minus 4 square root of 3x plus 4. So I'm going to subtract 2x from both sides. 3x I meant. Subtract 3x. And 4 from both sides. And I'm going to get negative 2x. The 4's over here, cancel out. Equals negative 4 times the square root of 3x. So in this case, we could divide off negative 4, or we could square both sides. I'll just go ahead and square both sides here to get rid of this radical. And what ends up happening is negative 2x squared is positive 4, because negative 2 squared is 4, x squared. Here we're going to have negative 4 squared is positive 16 times the square root of 3x squared is 3x. 16 times 3x is 48x. And so we're going to subtract that over to the left so that we can have 4x squared minus 48x equals 0. Factor out of 4, we get x squared minus 4, factor out of 4x, and we get x minus 12. And so we get potential solutions of 0 and 12. So let's plug in 0. Well, we could probably just do this in our head. 0 plus 4 is 4. Square root of 4 is 2. Minus 3 times 0 is 0. Square root of 0 is 0. Does that equal negative 2? Well, 2 minus 0 is 2. Does not equal negative 2. So we reject 0 as extraneous. Let's try 12. 12 plus 4 is 16. Square root of 16 is 4. Minus 3 times 12 is 36. Square root of 36 is 6. 4 minus 6 is negative 2. Does that equal negative 2? Yes, it does. So our solution is 12. All right. All right, let's go ahead and try another one of those. So first step, we're going to isolate our radical. So add square root of 6x over to the right. And that gives us square root of 15 minus x equals square root of 6x minus 3. And then we'll square both sides, which gives me the 15 minus x, because the square root and the square will cancel, equals, and I'm just going to write this right next to it. So square root of 6x times square root of 6x is 6x minus 3 root 6x minus 3 root 6x plus 9. So I'm going to combine like terms. I get 6x minus 6 root 6x plus 9. And subtract my 6x. Subtract my 9 to isolate my radical on the right side now. And I get 6 minus 7x equals negative 6 root 6x. Okay, so now I'm going to square both sides, which is going to give me 6 minus 7x times 6 minus 7x equals negative 6 squared is positive 36 times root 6x squared is 6x. So then I get 36 minus 42x minus 42x plus 49x squared equals, let's see here, 36 times 6 is 216x. Alright, I'm going to rearrange this to be in standard form. Combine my two like terms. That's plus 36 equals 216x. And now I'm going to subtract 216x. And I'm going to get 49x squared. Let's see, negative 84 minus 216 is negative 300 x plus 36. All right, so those are some pretty big numbers. So we're going to try and factor that. Okay, so we're going to have to factor this one by grouping, since our a value is not 1. And I realize these are very large numbers. I won't expect you to do something like this on a test. But 49 times 36 is 1764. And we want factors that add up to negative 300, which I've already found for us. They are negative 6 and negative 294. So I'm going to break this up, 29x squared. I'm going to do minus 294x, and then on the right, minus 6x plus 36. So now, on the left, I can factor out 49x, and I'm left with x minus 294 divided by 49 is 6. Here I can factor out negative 6, and I'm left with x minus 6. So this factors to 49x minus 6 times x minus 6. And so for potential solutions, we get x equals 6 and x equals positive 6 over 49. Once you set that equal to 0, you add 6 and then divide by 49. And when you check these, I'm just going to tell you, when you check these, 6 will work, and 6 over 49 is extraneous. So we will reject that one. Wow, that one was a little complicated. I will not give you anything that complicated on your assignment or on a quiz or test. Okay? All right, our last set of examples here. All right, here's our last word problem. And it says, the body surface area, BSA, of a human being is being used to determine doses of medication. The formula for finding BSA is BSA equals the square root of h times m divided by 3600, where h is the height in centimeters and m is the mass in kilograms. A doctor calculates a particular dose of medicine for a patient whose BSA is less than 1.9. If the patient is 160 centimeters tall, what must the mass of the person be for the dose to be appropriate? So over here in the picture, it does show some information. They're telling us BSA is less than 1.9. And they're also giving us that height is 160 centimeters. So, in our formula here, we have the square root of I'm going to put 160 in for h is less than 1.9. And our goal here is to solve for m, the mass of the person. So our radical expression is already isolated. So to get rid of that radical, we're going to square both sides. And so we get 160m over 3600 is less than 1.9 squared, which is 3.61. Now we're going to multiply both sides by 3600 to get rid of the division, which will give us 160m. We do not flip the inequality sign because we're multiplying by a positive number. And we get 3.61 times 3600 is 12,996. And then last but not least, divide by 160. And we get that their mass must be less than 81.225, and that's being measured in kilograms. Okay. And last one. A doctor calculates that a particular dose of medicine is appropriate for an individual whose BSA is less than 1.8. So this time we need BSA to be less than 1.8. If the mass of the individual is 75 kilograms, how tall can he or she be for that appropriate dosage? Okay, so again, here's our formula. Square root of h times m divided by 3600, this time less than 1.8. And this time they're giving us mass and we're being asked to solve for height. So I'm going to substitute 75 in for mass, so 75h over 3600 is less than 1.8. And we solve the same way. We square both sides, and we get 75h divided by 3600 has to be less than 1.8 squared, which is 3.24. Again, we multiply both sides by 3600 to clear the division, and we get 75h has to be less than 11,664, and then divide by 75, and we get that their height has to be less than 155.52 centimeters. Okay. All right, then down below you have a summary of both yesterday and today's notes as far as how to solve a radical equation. Always isolate, square both sides, solve, and check for extraneous. Okay. All right, you're going to get some practice problems for tonight, and then tomorrow you will get some extra practice problems just for this lesson. And then I will see you guys on Monday. Bye.